Hey everyone, it's Johnny Castles here from Prime Academy, and for today's example question, we're going to be focusing on how we can take the derivative of an exponential function. Now, just a brief refresher on what an exponential function is. It's a function that has a variable in the exponent. So you can see here on the left function, we have that x squared minus 7x all to the 3 in the exponent, and over here on the right, we have the 3x to the 7 minus 4x squared in the exponent. Since we have variables in the exponents, these are exponentials. And what's really great is that exponential functions have 3 basic steps, okay? And we're going to run through them for both of these questions. And so the first step is you're going to take the derivative of the exponent and put it in front of the function, okay? Now, what I like to do is I like to sort of write it as u equals, so this is me, just labeling the exponent as u. So there you can see I've kind of brought it down, and when I look at this, I can see that I have these brackets here as well as an exponent outside. So this looks like a chain rule situation. So to take the derivative of the exponent, I'm going to have to use the chain rule. And if you need a refresher on that, there is a video and a lesson, PDF of a lesson on the chain rule. So I'll be going through it a little bit quicker than normally, because at this point it's sort of presumed knowledge. So when I'm doing the chain rule, and I'll call this u prime because I'm finding the derivative of the exponent, here the 3 comes down in front. I then write the original expression, x squared minus 7x, and then I subtract 1 from the exponent, becomes a 2. And then I write the derivative of what's inside the bracket, and when I say that, I'm just referring to that part there. And the derivative of x squared minus 7x would just be 2x minus 7. So as I said, our first step, now that we have the derivative of the exponent, is we want to put it in front of the original expression. Don't forget, this is the original expression. So what we're going to do is I'm going to write this now as y prime because we're starting to find the derivative. So I'm going to take this big problem here, this big expression, so the 3x squared minus 7x to the 2, then I'm going to go 2x minus 7. So there's my first step. The next step is you're actually going to rewrite the original expression. And again, what I've just circled in blue, that's the original expression. So then I write times 4 to the x squared minus 7x, and then to the 3. Let me just erase that bracket there. That's a little bit sloppy. There we go. Close that bracket to the 3. And then the final and third step is I'm going to write the ln of the base. The base in this case, when I look at the original expression, the base is this 4 here. Okay? And I'm going to let those, so I'm going to circle it again. It's the 4. So then I'm just going to times that by ln 4. Kind of a long and messy looking expression, but nonetheless, these are the 3 steps, and I'll choose a different color here. There's sort of step 1, which was again the derivative of the exponent, step 2, which was rewriting the original expression, and step 3, which was writing the ln of the base. To fully simplify this, what we could do, and I'm going to do it here quickly, is where step 1 is, which is this whole expression here. You could do some simplification here. You could multiply the 3 into the 2x minus 7. So it would become 6x minus 21, and then x squared minus 7x to the 2. And then now I'm going to write my step 2 again. No simplifying to do there. X squared minus 7x to the 3, and then times ln 4. Okay, let's do an example with e now, and I'm going to just sort of scroll up. Actually, first I'm going to have to do that and then drag it down. So what we're going to do next, same thing. So the first part I'm going to focus on is taking the derivative of the exponent. So I'm going to call it u, and I'm going to write u equals 3x to the 7 minus 4x squared. Now these are just 2 monomials being subtracted, so I'm going to use the power rule. So the 7 would come down, and I would get 21x to the 6 minus 8x. So now I've got the derivative of my exponent, and I am now going to write the expression out because I have my step 1. So my step 1 is 21x to the 6 minus 8x. My step 2 is rewriting the original expression, which is e to the exponent 3x to the 7 minus 4x squared. And then the third step is I take the ln of the base, so there's ln e. A little bit of a log review or logarithms review. Step 3 here, which I'll write the little 3 underneath, ln e always equals 1. So this here will always equal 1. So I guess our last step of simplification would be rewriting steps 1 and 2 again. And then step 3 we wouldn't have to write because essentially you're just timesing or multiplying by 1. And there are 2 fully worked examples of how we find the derivative of an exponential function.